All right, let's hear some more about architectures from Grady Booch, the creator of UML. Hello, I'm Chris Dennis. I'm a KMP developer. Tech support said they're coming out Tuesday. Just shut that portal finally. We'll see. Okay, I'm going to continue on with part 3 of me ranting about Grady Booch and some of his ideas about software for architecture, some of it I agree with. I appreciate where he's coming from. I appreciate that he's been influenced by Alan Kay. And I do appreciate his business grift, but one of the things I'm wanting to do with this channel is to call out some of this grifting stuff because I've lived through all these phases and I've been the guy that's been told, no, don't understand it, you're just not doing it right. You're not fully aware of all the concepts. Like, yes, I became aware. So I was like, okay, well, I'm gonna try it out. So I've had time to go down these rabbit holes and discover these things and what they're really talking about. Listen to like old video interviews and all this other stuff. I haven't done this with Booch, but I've done it with these other characters. And there's always some little spin they're putting in there with a lot of gish scalping, a lot of marketing, a lot of like unaware of things. Like they talk about they don't write software that needs to be written for software's sake and not for any economic purposes. But they find out later they've been buying and selling companies and getting rich on these marketing plans and working at big major billion-dollar companies and etc. etc. Here, so let's keep going. Let's listen to Grady what he has to say about software architecture back in the 2000s.
Here we're talking around 2000 plus or minus a few years. Remember that Microsoft was big in the midst of this as well too, that they actually worked with us to take our Rose product and make it a part of Visual Studio.
No wonder people thought that, well, you put it in Visual Studio, they figure, well, it's like let's hop, skip, and a jump to do code generation. So yes, even though Grady was saying, no, we just dissuaded that, don't do it, but you made a language that did it. You made a language that did it. The output code from UML to source code, and then you worked with Microsoft to also put a UML diagram in their coding system. So you can see where people were getting this a little bit combined together, where you just go from the UML right to the code. You can't see how that.
So we had a team that was working up in Seattle to make that happen. And it was a major selling point for Microsoft at the time because it.
Yeah, not the UML crap, the diagramming. We've had drawing tools, dude. It was your marketing, which I respect the grift. It was your marketing of UML as a way to break down any problem, any particular software problem, using your tools to then generate code that was extensible, easy to understand, reproducible, reverse engineerable, all the stuff you say that you use in there. So yes, that's why they're excited, not because you're diagramming UML specification. No, it was what you're saying the specification was going to do for them, which is going to solve their stuck, failing software projects, over budget, over time, can't figure out how to fix them, can't figure out how to get them move forward, taking heroic efforts on everyone's part. They're talking about the 80-hour work weeks. It's that stuff. Well, that's how we created it. It's like, that's a problem. Engineers, they don't work really well. The knowledge workers don't work well when they're burnt out. They will just cut corners, which, what does that do? What does that do? In software, what happens when you cut a corner? Buggy? No? Never heard of it? Okay.
It actually helped their customers build more complex software. So yeah, we're talking around 2000 or so. But what else happened in that?
The building of the software is not the hard part. Any ding dong can build a big piece of complex software. It's like having somebody else understand it, maintain it, update it, change it, fix it. That's the hard part. Not the building complex software. It's like, that's not the issue, buddy. I know he's like super enamored that the computer can do all this. Wow, we can create complicated software. No, it's not the issue anymore. Now it's just like, how do we maintain this pile of crap?
That time frame. The answer is the internet was, so the ARPANET had moved over to the internet. We were beginning to see companies in the late 1990s move on to the internet, which was great. But there was a challenge.
It's the ARPANET. What are you talking about, man? It's the same thing. The ARPANET is the internet. What are you talking about, man?
There was first, how do I even build systems for distributed work in the web, and how do I make money off of it? What does those systems look like? And so,
so it's not economic driven. Wow, Grady, I don't know how unaware you are about this thing, but the fact that you're working at a billion-dollar company, you should never talk about how this is not economic. You should never talk about software being not economic, okay? Acquiring companies, selling them, making billions of dollars, be able to wear a Hawaiian shirt at work and be able to give yourself a title, whatever title you want.
So that's why Microsoft was interested, because we were helping their customers move from the PC to distributed systems. But on the other hand, there was also
I mean, distributed systems is just a whole other can of worms. Like, how do you? It's all APIs. It's not really different from having the difference. This is what Alan Kay was made it clear. It's having something local or having something remote. It doesn't really make a difference if it's using a messaging. Yes, there's latency involved. There's like time to transmit, but there should be no conceptual difference between these things. And that's where it's like people are still, you're trying to come up from this procedural oriented world and jam in, and without having to give up the tool set, jam in this Alan Kay style model and still like get the performance out of it. Eking every little microsecond out of it. Yeah, at what cost? The cost is this complexity, these things that can't be maintained, that can't be updated, that can't be changed, and nobody knows how they work.
a lot of hype that the
Yeah,
internet's
I
going to
wonder where the hype came from, buddy. Like, so obvious that this guy has like, you're pumping it, man. You're pumping it. You, Grady Booch, you are pumping the hype, man.
improve your sex life. It's going to do all these kinds of things. It was just
Yeah,
total.
yeah, because you guys were pumping it, and it was such a major issue, and the sales guys figured out this was the major objection: is how can this language fix this issue, which is the maintainability, usability. How do we figure out that make it so complicated? Yes, we've had a genius go write this thing for it. It's a big complex thing, but nobody else understands how it works. And how do you do that? How do you fix that? It's like, well, we've got a new language, and it's a UML diagramming issue.
Totally overinvestment in that space. So a little after the millennium,
Totally overinvested. Oh, you mean it was a bubble? A hype bubble? What? In tech? No.
we saw a backlash, and there was this great downturn in the marketplace.
Yeah, because you lied to people and they figured it out eventually when people were so gung ho about making all this stuff work that you said was the most greatest thing ever. And then we figured out it ain't. And then we go, fuck, what do we do now? And there's no that many other you guys hucksters out there. We're kind of a little gun shy now because you've been lying to us about what these things are capable of and who can use them and what for what reason. Because you've got your hyper, was it hyper where they emit a lot of information? Hypertetrosis, what is the guy of Scientology? He had it. L. Ron Hubbard, he had this issue. And it was a diagnosed like psychological issue where you type a lot of shit and you just output a bunch of crap and some of it sticks, but most of it's just garbage. I think it's kind of like that. It's like, oh, someone's paying attention, but this guy's a little smarter than that. He's doing a sales thing. I respect the grift. Don't get me wrong. I just want to say, be clear, because no one's talking about this. No one's discussing this because they have seen it not long term enough. I don't know. I've been doing computers since I was a little kid, so I've seen a lot of this crap go around and around and around. And we used to talk about it when we were being purpose, and now they've got this intermediated system of internet video, whatever the hell this thing is. It's like it seems to be gone under the radar. We don't talk about how the grifting is in with these guys. And it's like, well, we overhyped it, oversold it. I wonder why. Didn't you tell them it was going to solve all their damn problems? Come on. And he's like, why? Well, it just all of a sudden fell over. It's like, didn't you kind of caused it by overhyping it? It was going to overextend because they were planning on this thing, letting them take him to the moon and back, and it was only going to take them around the corner. Come on.
Where people had built things and realized they weren't necessarily economically sustainable. So
So economics is part of it. Even though in the beginning you said it wasn't, it shouldn't be part of it. It's like definitely part of it. What do you think's going on here, man? Like, we're solving people's problems with software instead of doing it by hand. We're trying to figure out ways of building tools and systems that facilitate that and don't have more problems building the damn system than fixing the problem that we started with the first place.
So now we are here in 2003. IBM and Microsoft were still using our tool.
And we got these grifters coming out here telling us, no, we have ways of doing it. It's just you do it our little special way. It's called the Broody method. Broochie method, whatever the hell it is, Gucci. You have to do the Booch, right? Do the Booch. We learned to teach you the Booch and go to the courses. We got books. We got conferences. We were doing panels, talking about it, classes, training professors. And everybody gets booched out. Everyone's booched up now. And then now what happens? Well, where's the results? Well, damn it. It's these things in the middle of the Booch method between the move and the results called people. I know it's crazy. But everyone's got their own way of doing stuff. And most of the people are just trying to copy something else and not really think about it too deep because it's hard. And most of the time you're wrong. So yes, it's extremely painful. Every business guy wants to go right to the result. Well, if we had that, it would already be here. We wouldn't be thinking about it, talking about it. We just be, there it is. It's right there. It's right in front of your face. So no, we have to go through this damn struggle. And nobody likes to pay for that struggle because there's no guarantees at the end that you're going to get there. And all these business people have been told at their MBA at Harvard that they're going to be, this is a process. Everything's a process. You can put everything into a series of steps and reproduce it 1,000 times and ship it across the universe and make billions of dollars. It's like, but that's not software. We're trying to figure out what the thing we're going to make. For who? For why? For what reason? This is why we're doing. This is why it's so crazy and costly. And you can't put a system around that until you figured it out. Then you can put a system around it. Yes. But figuring it out, what problem people are willing to pay for, that's really hard to figure out, man. Everyone's like, no, that's not it. No, it's this coding issue. It's how you break the problem down. It's like, that's not the issue. Yes, that you have to pay attention to that, and you have to like stop listening to the guys like this who got an answer to all your problems. That should be a little clue. Like, anyway, these guys that comes up and says, hey, I got an answer to all your problems, dude. And people go, you do? Really? You sound real smart. And you know lots of people. It's a small world to you. But these people are giants in the industry. And they have blogs and conferences and courses and training programs.
Tools heavily because they were important for their customers. IBM and Microsoft both bid for us, and I think IBM won at some bid of $2.7 billion to buy Rational. And so we went over to IBM and became part of it.
Was it $1 billion or $1 million? Because that's quite a bit difference, buddy. Was it $1 billion or $1 million? That's quite that's a pretty major chunk just thrown around with orders of several orders of magnitude.
And that made sense because at that time there were 3,500 of us in 14 countries. We had
Whoa! Holy smokes! What were you guys making? You must have been making some really amazing software.
Almost $1 billion in revenues, which was pretty extraordinary for a company around that time. But it was time to be absorbed. Now,
why was it time to be absorbed? Just it was time. Maybe you guys were coming to a dead end and really weren't producing anything. It was time to bail out. Well, you still could. Now, whoever do they make any software that anyone's ever used? I never heard of them before. Defense Department shit with unlimited budgets. Ooh, wow, that's real challenging work. Well, you don't have to deliver anything. You just deliver bullshit, and you say, "Oh, it's be the extra week. We got the sprint running. It's got the problem thing going." Oh shit! Oops. Okay, I accidentally hit the keyboard. Let's keep going.
Now, one other story I'll tell before I pause again. Here I was. IBM acquired us. They made me a fellow immediately, which had never happened before. It usually takes years of being part of IBM. And a couple of months after, I got a phone call. It said,
"This is interesting. Acquired for $1 billion, though. You're gonna get something. A new fellow. You better get a new fellow. He's gonna invent UML. Have you heard of it?"
"Hey, Grady, it's Bill. Come visit me." So I went up and flew up to
Bill Gates, right?
Bill Gates, yeah. I'd done some things with Bill before. And so Bill was at the time still CEO of Microsoft. He said, "Hey, Bill," took me into his office. We had a 30-minute meeting scheduled. We ran for 2 hours, much to the annoyance of his staff. And he sat down and said, "Grady, it's not public yet, but
what else are they doing? Annoyance of his staff? Who gives a fuck about their staff? I mean, you're $1 billion company, just got bought, sold, whatever else we're gonna call it. Screw the staff. Shut up. They're making hundreds of thousands of dollars a week. So what do they care? All they do is meetings. Come on now.
I'm going to be moving out of my role at Microsoft because I would do other things. And Grady, I've got 2 roles. I'm CEO and I'm chief architect of Microsoft. I'd like to give you that job of chief architect for enterprise." And so I said, "Bill, that's very interesting." And so I said, "Give me a little time." And I went around and met all of his main reports. Most importantly, Ballmer never met me, and that was a red flag. And it was around the time too I realized that Microsoft was a particularly nasty company. You had the Office group, and you had the Windows group.
A particularly nasty company. I wonder where they get that trait from. One of the things I've learned over time was give me involved all these different companies and corporations, whatever the personality of the guy, the CEO, not the board of directors, but the CEO guy, who does the hiring, firing, and sets all the patterns, what we're trying to do, how we do stuff, how we make deals. That kind of sets the tone for the entire organization. So yeah, a little insight into Microsoft.
Just couldn't stand one another. So I eventually came back to Bill through his hiring folks and said, "Bill, I'm flattered, but you have a profoundly dysfunctional company, and I'm not the one to fix it. So, Bill, thank you, but no thank you." I think I used something to the effect of, "It would only end in tears for both of us if I accepted. So let's move on. So I stayed at IBM, and it was a good decision to make. It would have been a bad decision for me to go.
And there's this cartoon about
And these are the people we put in charge of our technology and our world and pushing the jabos and all kinds of specious stuff, sending mosquitoes around everywhere. GMO'd mosquitoes. Like, what is this going on? Who are these people?
Microsoft, created by a software engineer cartoonist, Manu Cornate, about the organizations of Microsoft, the two organizations, and they're holding guns against one another.
Yeah, that's where it was. They needed somebody to knock it. I'm a lover, not a fighter, and I was not the guy to break things up.
Wow, what a story. So I studied UML in
Pretty
college,
common,
and
though.
to this date, it's part of several
Just reflects the leadership. That's all it is.
college curriculums. But interesting enough, in the industry, I've just not really seen it used for anything, at least the companies that I worked at and the startups and scale-ups and large companies I work with. I kind of see a resistance to using it when it's brought up, claiming that it's too formal, because we do use architecture, right? We use boxes and arrow.
It's not that it's formal. It's just kind of pointless. We're already going to do boxes and lines there. We're going to clear what they are anyway. We're not going to go clear it with, let's go clear it with the Booch. Hey, is this part of the Booch protocol? We don't give a fuck about that. It don't matter. Look, man, his thing about, oh, you do it all the way I say, it'll solve all your problems, that failed around 2000. 2003, 2004, we were like, nah, man. Nah. And when they integrated into the tools and people tried it out and they was like, okay, and they tried to scale it up, they're like, this don't scale, man. This don't scale. This is more like an idea tool for sharing information. But we can just skip your shit anyway. We don't need it. We're already doing lines and boxes and boxes and boxes before this. So what do we need Booch for? And Booch's like, oh shit.
And
Better sell my company.
we diagram. I'm curious to know.
Yeah, we diagram boxes and arrows. Exactly. We already diagrammed. So what are you talking about?
Talked about how UML was used by 20-30% of the industry at some point. But
no, it wasn't. See, that's the lie. That's a lie. You need to supply information that's real. That's actually not how things were. That's definitely not. There were not 20-30% people in the software industry using the Booch method. Come on now. Maybe 2%. I'd say 2%. Or that's max. Max. Who even heard of the Booch method?
But what happened in your view?
So this leads us to, contemporary architecture.
Let's see what it says.
I've got a shelf full of books on architecture, both in the, older ones and new ones. And if you look,
what does that mean? So they're on the sales circuit too. They're all punching in conferences and doing tours and getting training programs together and training materials and doing presentations about how to improve your development process. You're stuck, fucked up, dumb, messed up development process that you can't figure out how to fix. Yeah. Oh, wow. That's amazing.
Look at what a lot of people speak of as software architecture today. I think it's reasonable and sound, and there's good stuff there. But in many of the kinds of systems these architects talk about, the architectural decisions have largely been made for you. I'm going to build a system that requires message passing. Well, let's go find, Rabbit MQ or whatever, or Redis or whatever I need. The architectural decisions have been made for you. So a lot of the...
I mean, but what the business does and how these processes work and where the customers are, what they want to see, what they don't want to see. I mean, if you're going to use some kind of general purpose tool for your back end, you're like, well, yeah, I want to use something that's been battle tested and for doing my little use case. If I can Lego piece this thing together, yeah, but there's going to be some part where I need to write some code to do it. But yeah, for the pieces where I don't, why not? And that's not actually architecture. That's just like these components of how you put these things together, where, I mean, you can write yourself if you really want to, like I have, and there's times when it's useful, but then there's also times when it's not, when it's like, let's use something off the shelf where we can already have some monitoring on it and some kind of thing that we can lock into. We don't have to do that right now. We have to work on that component. We can just let that be our way we just do stuff. And there's all this open source stuff now. It's all been battle tested, battle hardened. So yeah, but that's not really architecture. That's just components of things of architecture. It's like architecture is the hammer. No, architecture is the design, the meetings, the placement, the zone. Like, what are you actually building? Are we building a school? Are we building an office building? Are we building a house? Building a 7-Eleven? What are we building?
Activities of contemporary architects is simply taking very large frameworks and components and weaving them together, which is a very noble and wonderful thing to do. They also represent systems.
We're economic, man. It's economics. You want to roll your own of all this stuff? I mean, there's times when you may need to. It might be useful, and maybe it will save more to do it the simple way. You just need one little thing. But if you had a whole bunch of stuff that needs to go, have a bunch of requirements and need to do certain things, you might have to buckle under and get it, take on one of these damn open source projects or some commercial project and use their stuff. If you can figure, and then that's a whole mission in itself, right? Just understanding what these things do from all these companies, which are exaggerating, and you have noticed some of the stuff is like, how much is this going to cost? Or there's some variable pricing thing at the beginning. It's real cheap, and all of a sudden it ramps up when you want to leave.
Systems like Meta and done in particular, they have grown their architecture and system over a few decades now, and the stuff they're building on top of it is largely evolving and building upon those APIs, which does not require the deeper kinds of architectural thinking.
Really? Are you sure? That's a pretty deep. That takes a tremendous amount of skill interweaving all these different systems together. You say it so trivially, like it's like an offhand remark. It's like, no, these things are super complicated. Even just even with AWS, they have what, 250 different products. Even just figuring out what the one to use that may be useful for your use case and not be raped as well. And then you have to all these other decision matrices that are much more about like economics. I don't know what else to say. Like, we're paying costs somewhere, right? There's going to be some costs somewhere. Where do we want to spread out to where we get the most value and we can leverage other things too? I mean, maybe using AWS is not the good idea. Maybe you should use a Raspberry Pi.
So
see, it's the way this guy talks. It's the way he talks. It's sort of like I'm still stuck in a time zone like in the 90s, 2000s. He's still stuck in that mindset. It's like, man, you've been selling in these companies. What do you think people are buying now? I mean, come on, what the hell?
Oh, I use this. Let me give you an image here of a 3-axis system. Along one axis, you have levels of ceremony. If I'm a startup, then it's just my other people's money and no one else's. And heck, I can write disposable software. And if I fail, I'll just go find another venture capitalist. Of course, I'm not going to worry about any kinds of degree of ceremony because just build it. Go hire some brilliant people and make it happen. That's wonderful. On the other hand, if let's say I'm doing something like, I don't know, building the next generation intercontinental ballistic missile system, which uses about $500 billion, you bet you're going to use more ceremony because you have to have degrees of accountability. So that's one axis. The next axis is that of risk. So if I build
How about accountability with some of your statements? How about accountability of like what you've said that people should do, and when we did it, it didn't work. And instead of just saying, "Oh, I just failed," it's like, no, man, you got to reconcile that. And the fact that you pumped all this stuff in and it didn't go anywhere. Why? Why didn't it go anywhere? What was the gating factor, sir?
the system and says, "Oh, if I fail, so and so's not going to find their grinder match." Big deal. On the other hand, if I fail and somebody dies, that's a problem, and you're going to use a more disciplined architecture.
Architecture or disciplined methods? Architecture? What is a disciplined architecture? What the hell does that even mean, man?
Third axis is that of complexity. If I build a system that people have done again and again, then heck, I don't need anything. Heavens, this is where prompt engineering comes into play. I go build an app just by building prompts because we built these things.
You have to demonstrate that's even a thing, even more complicated than the demos that they actually show. The stuff is, I mean, end to end of things. I mean, toys and DSA problems, but end to end applications, full blown application with login, all that stuff. I've not seen it yet. Other than a to do app. What about something different than a to do app? I haven't seen it yet. So we're still ways off. It's like writing the little glue code and the lower level stuff from a prompt. Yeah, that's pretty cool. That actually works pretty good. But like the full thing and then using just prompts, I haven't seen it.
I don't need no stinking UML for that thing.
Yeah, we don't. We don't need UML general, sir.
On the other hand, if I
obviously, because nobody uses it,
building something that I've never built before, let's say I'm building not an LLM, but I'm building a constellation of LLMs work together, and I want to weave them together with non-neural systems, then you begin to think about architecture, and that's where the UML comes into play.
Does it? Is that where it comes into play? Okay.
There's a sweet spot for a tremendous amount of software development going into place that doesn't need the UML and does not need any kind of thing like that. But on the other hand, you go a little further out in that 3 dimensions, and yes, there are people all over the place using UML. I mentioned the James Webb Space Telescope.
I mean, could we also just use regular diagrams? Why do they call it UML? I mean, I'm sure the Space Web Telescope people have defined their own terms about what all this stuff means, how it all works, and what they mean by doing all these things. Because you can't put those in a fucking UML diagram, man. No matter how much you want to do that, it's not going to be the UML. It's how we communicate these ideas together. With the line to connecting things, a box, which is a conceptual landscape, and then a boxes within boxes, which are the conceptual layers, which I go into on my free course, How to Program from the Ground Up. I go into all this stuff called, visual design is key part of how this is done, but not your UML, the Grady Booch method. Come on, man. You gotta like that ego thing. I let that shit go, dude. It's like, this you're losing people.
I still work with financial companies who are doing that, where the risk, the complexity, the ceremony is
Right, but okay, so I mean, yes, I guess, but those could be. Why do we have to call it UML? Why do we have to call it all these crazy acronyms where people think that if you go study, then go into the detail, you're going to get more out of it than just a box, a line, and like boxes within boxes, and then just talking about these things in this way, so we can like share the model we have in our brain with other people who are also going to build their own models anyway, and then we can just share the information together without another interference, like with no, I'm Booch. Gonna do it my way, or you're not booching it up with the UML rightly. See, you're not really a web telescope, are you? You're not a major financial institution. I mean, yes, banking and all that stuff. Yes. What are we doing with banking? But like, are you doing an operating system using UML? Like all the things with the source code. Why do you need to do it? Why do we need to use a UML? Why can't we just do lines and boxes?
sufficiently high that it demands a bit more formalism.
So do I understand it correctly that you're saying that
Right, but why do we have to do your formalism? We're going to do our own anyway. We're smart people too. We're not just like, duh. And the fact that you try and dumb it down and make it seem like your system's going to fix all the problems is making things worse.
software architecture has changed from the 90s and 2000 when systems were new, architectures were new, software architecture was still a lot more novel. And if we look at venture-funded startups and big tech today, what we see is, one, they're just not as risky. If they fail, big deal. And then two is we can use a lot more software that's out there.
Because they're not as expensive, because you don't need as many people, because we can use these off-the-shelf tools to put things together and make stuff work. Well, this is not, it's like, who wants to rewrite something if we already have something that's going to work enough, which people have been working on to solve these kinds of problems that are very common for humans, to solve problems on humans. Look, man, every line of code is a bug. So we're trying to use the minimal amount of code, right? I know this is a shocker. We're trying to use the minimal, at least people who are trying to do these businesses are trying to use the minimal amount of code, because the minimal amount of code is a less surface area for things to go wrong and get crazy to solve the problem that we've designed, that we want to solve for people. We're not trying to, so if we can use tools that make it easier for that process to happen, we will. How the software is written and what the architecture is and like all this shit is side quest. The primary thing is like, how can we solve a problem economically for people easier than they're doing now? More fun, cheaper, more accessible, easier, all the things. It's better somehow that we found out that people are willing to pay for. What that? This is not rocket science.
Been architected, and we can, for example, use Redis as a cache, and it's there, it works. We don't need to think too much about it. And then the third is that there's
right, but we're gonna write it again and go through the bullet testing and bulletproof testing and all the billions of transactions Redis has already done, that just to get to the end result as being the same thing. Why don't you just use Redis? This is it's like, we're not doing the software engineering of the memory cache Redis. It's like, who wants to? We just want to get data in and data out efficiently without having to do a crazy multi-tiered, what's it called, microservices, crazy bundle of Kubernetes. I just want to use Redis as a fast cache, and I don't want to write my own, because I just want to trust that thing's gonna work and I can scale it. This is not like, that's a whole thing, right? Making this stuff scale, replicate, and then testing it. I don't want to write my own of that.
A lot of startups who just don't need ceremony. Basically, they don't need audits. They don't need formality. They can just go like, all right,
yes,
right,
because you're trying to market fit. All that stuff can come later. But without market fit, what are you going to do? Like, there was a whole period of time where people were like, that's just the normal thing. It's like, well, kind of is. Finding ways to apply computing to solve a problem profitably. I mean, that's the goal here. Not can we use the most maximal software possible? It's like, no, that's not the point. Missing the point.
Do it however we want to. We don't need that kind of auditability. Do I understand that these are the changes that are in play with software architecture? And is this why like some of these formal methods are just not as popular with startups and scale-ups?
Yes. In fact, I think it goes to the root
Of course, we don't have time for that. Look, man, a lot of the times the runway is like a year, 6 months, and you just added 3 months just to do UML diagrams. We don't got 3 months, buddy.
the economics of software development. Let's go back to the first age of software, first golden age. The machines were far more expensive than the humans. And so it required one to do,
which were just because the humans, let's be honest with that. It's not the machines were expensive. It was the people who had the skills to create the machines are hard to find and rare. And we can maximize the profits of having to go find and train and keep those people going with their families and all that stuff. That's the price of the machine. If there's only 16 people that want to buy this thing, well, it's going to be expensive to keep all those people employed and having dental work and college funds. Come on, man. It's economics.
do some thinking before I even got to the machine, because machine time was very, very expensive for me. And so
for you it was, yeah, because they had other customers who were willing to pay thousands of millions. Because how were they doing it before? Lines of people with spending machines making all kinds of mistakes. So yeah, it was totally worth it. It was less costly than rooms of people combing over spreadsheets, doing calculations, and making errors and being annoying like programmers are, right? If we just get rid of these damn computers, which are human people, like doing these calculations, that's what the computer replaced it. So the computer replaced the computers, which were computer people, So the computer replaced those people. So yes, that's how they could charge a lot, because you were asking to have people work. This is how they thought about it back then. Booch, you were asking a bunch of people to go through and do some calculations for you. Except instead of calling them people now, we call them this electronic machine. But we're going to charge you for the same. So this is where it came from.
yes, algorithmic decomposition, structured analysis, design techniques made a lot of sense because we needed that kind of optimization. If you move to contemporary times, computational resources are like water to a fish. They're available to anybody. I've got on my desk behind me, I've got
yes, but to apply them to human problems, you're just talking about compute cycles. I mean, people have watches. I mean, what does that even mean? Yes, there's more computers available, but so what? What is that? But are they being applied to human problems? That it's like, who cares? There's just lots of compute available. Yeah, but when you apply them to a human problem, I wish I could explain it better.
My own personal cloud of 4 NVIDIA single board computers, which has more processing power that existed in the world in the 1970s. And that's pretty amazing. That's a few $1,000s there. Okay. And so the economics have changed vastly, such that you don't need to think about it so much because, heck, it becomes disposable.
Right. The processing power is cheaper, but the price of people putting their kids through college is now through the roof. So that's even more expensive. So trying to find a niche to find a problem that could be solved, that economically is difficult. That's where the challenge is. But if you can find one and serve a niche, which is like the bunch of shows on that too, on this channel, yeah, that's the whole thing.
AI is.
Who cares how much the compute costs now? It's like now it's the cost of figuring out how to get this thing to market. It's like, oh, you got 6 months runway, yeah, because that's how much it costs. Like that's how much time you have to figure it out. It's either self-funded or VC might fund it, and they're like, oh, they're going to want to see some results in a couple months. Some kind of product market fit happen, otherwise it's just pull the plug.
I think is also changing that, because it allows me to build things where I don't even have to think about design. Heck, I don't even have to think about software. I just prompt it for those things to build.
That's not true, sir.
Something.
That's not true. That's like what people want, but that's not true. That's not quite how things work. You can do simple stuff. It can be part of an architecture of other things. You have still to think about software. You have to think about code. You still have to think about how these things are put together to do anything useful more than the trivial.
And once I'm done,
what are you talking about?
So in that sense, it comes back to the economics. But there will continue to remain a class of software that's new, unique, breaking new ground that still requires that kind of architectural thinking.
And it's interesting because just recently, I read how Amazon is using formal methods for AWS S3. They're publishing a blog post detailing like how they're doing it, and they're doing this to catch those really, really edge cases that only happen in 1 in a billion, 1 in a trillion. But
at scale, it makes a difference. At scale, you better have something that catches all those cases. Yeah, Yeah, once you're scaling up, but in the beginning, so there's a different issue in the beginning, right? You're still talking about market fit, so you don't have to worry about this crap, this formless crap. You may have to at some point, but we can get this formula stuff. I mean, having it just having it documented and having these pictures, these diagrams put someplace, let like code generate them instead of having to redraw them every time something changes. You just have how the modern UML, mermaid UML stuff works, which is not even the UML that Booch is talking about. So there's all these confused terms that mean different things to different people. That doesn't make things hard.
Their scale, this is a regularly reoccurring event. And I found it fascinating how some of these methods are making their way back.
Yeah. Well, let me set aside formal methods in a moment because it turns out that's a different topic for which I have some experience and opinions. But go back to Amazon, you go to their websites and they have a whole language around architecture. Microsoft does as well too around Azure. It's the way I describe an architecture.
Their own language, right? Their own meanings. Oh, look at that.
In Amazon, it's those, their blocky diagrams. It says, hey, I'm going to build this kind of thing, and here's my particular notation for it. And furthermore, here are some examples. So even Amazon and Microsoft have recognized that architecture plays a role. But there are enough times people have done these kinds of things. It says, oh, you want to build this kind of system, then you want to use these services. In fact, here are some examples for it you can find on our website. So
they want to lock you in, of course. Yeah. But, there's usually an open source alternative. And usually you may want to not be that as your first stop for you're doing MVP when you're still trying to market fit. Maybe you don't want to use an AWS. Maybe you want to use a Raspberry Pi. If you're doing the real startup stuff, which is, self-starting.
Without them really acknowledging it, Amazon and Microsoft view architecture is still important, but there are enough patterns.
Yeah, what are you talking about, man? Yes, architecture is important. You got to know how things are going, what your thing is doing. This guy, I don't know. Sometimes he just talks just kind of in circles.
Patterns that one doesn't have to go through the process of rediscovering those because I can build those things. And this is a representation of the maturation of our business. We move from algorithms, which everyone can use, to design patterns, to now architectural patterns, which Amazon and
design patterns,
Microsoft have codified themselves. So let me switch over now to formal methods. Formal methods have always been a thing. However,
they have really always been a thing, really. Formal methods have always been a thing. What does that even mean?
Experience have been a niche part of every software-intensive systems because formal methods only go so far in what domains they can cover. And so you'll see,
no shit,
is what your example described. Microsoft began using formal methods in their drivers to validate the correctness of their.
Are you talking about doing test suites, like checking to see if the code works and is exercised in all the edge conditions? What are you talking about? Is it formal methods? They're talking about testing. See, they don't define. He doesn't define these terms, man. He's just like scalps along. Oh yeah, if it's formal. The people like, see, this hypnotic induction techniques. I'm not sure if he's doing this intentionally or not, but it's definitely a thing that you're gonna like. People will learn over time so they can sell their stuff, man. Or like doing sales here.
Things
their hardware driver
with their hardware, exactly. Yeah, and that was an important move forward. I've been with projects that use things like, I've got this system in which people might die, let's run a formal analysis upon it. The thing,
what is a formal? What do you mean formal analysis? Do you have a bunch of inputs and expected outputs? I mean test suites? What are you talking about, man?
The thing is though that those formal methods don't deal with real world things because they don't deal with space and time. They deal with functionality.
What? Dude, see, scalps just deals with space and time. Boy, now you're in the sci-fi world, sci-fi land. He's a little loopy, man. He's a little loopy. I'm just saying.
So I've always found formal methods to be of use, but only for parts of a system and never as drivers of the architecture itself.
What does that even mean?
Speaking of software architecture,
it's just so random. It's just like that's a googly book of words. Like, what is that even mean? Am I freaking out here? Like, what did you just say? What?
Sure. These days, the role software architect is not really popular anymore, at least at the likes of startups and big tech. Instead, we do have architects, but
yeah, because there's blowhards that don't code. They just do the UML diagrams and make the programmers take over all the details, which is where the hard shit is, or has been at least. Now the AI actually makes it a little more tolerable, that we don't have to go to fucking Stack Overflow and get mentally abused for asking a question. This is a duplicate question. This was asked 2 weeks ago after thread number 684. You should have read the report. Like, what the hell? You have to get therapy, mental health therapy after asking a question on Stack Overflow. Now I've got 300 points. Woo! But I wasn't even trying to answer questions for a long time because I was just like, dude, these people. So eventually I was like, well, if I feel like it, I'll answer something in there. I'm not going to listen to the comments. Dude, I was just like abusive. abusive. How that platform was able to stay involved. So yes, the AI tools that having to go over there, that mess. The tools make it a lot easier. But you guys still gotta know how everything works. You guys still have to know the details. You guys know the quirks and all the weird stuff. There's been no platform underneath that's changed. We're still writing code to the same shit. It's not a magical new world. It's like we're still writing on this old bullshit crap. Like I'm an Android developer. The amount of cruft and leftover junk and like half-baked ideas and not fully thought through and just throw it out there to see what happens and not scalable, claim it is, but you go in there and try and scale, it's like it's a nightmare.
Including called staff engineer, principal engineer, distinguished engineer. The architecture
All
is,
these titles.
and they do still do architecture, but there's a different focus on it. Now, you were there when software architecture was created, when the first software architects were.
It's been architecture the whole way. Even before we had electronic computers, we had rooms of people who were doing different things, and there were people doing these calculations. And then we went to tubes, and they still had the same rooms, the same equipment in there, and there was equipment and machines and people to doing all the things. The people were the processors, and the machines were the processors. They were processing things together. It's been constant the whole time. So architecture design, how banking and all the systems work, and how you mail stuff off, and the tapes would be coming in from all the different offices, and all that stuff. It's architecture.
Created as a role. Can you tell us how you've seen this role be created and then evolved throughout the decades?
So two things influenced my understanding of the space. First is I didn't really call myself an architect, but I helped people design the systems they were building. I was heavily influenced by a dear friend of mine, Mary Shaw. She's a professor at Carnegie Mellon. I think she won the National Medal of Honor under Obama, if I'm not mistaken. And she wrote this really profound book called Software Architecture, in which she began the first exposition of architectural patterns. Mary's just a delightful human being.
Really, the first? They've been talking about this shit the whole time. Get the fuck out of here, man.
And that's when I began to understand the formalizations of what architecture could be. And the other thing that influenced me.
Formalizations of architecture? Are you serious?
It was architecture from other domains.
Stop with that shit, man. It's common sense. It's business. It's finding a problem, figuring a solution, going through a bunch of solutions. If most of them are not going to work, you're probably not going to even have a business. But you might get lucky, or somebody might come to you and say, "Look, we got to find a way through this whole thing." You're like, "Oh shit, we got to do this now." Or some new technological breakthrough, and you're going to take advantage of it, try and get to market first, so you can sell your company, so you can retire, so you can get off the hamster wheel of all this crazy shit and listen to people and go to conferences.
Particularly civil engineering and the like. And there's in the defense world, there's also shipbuilding architecture and airplane architecture and the like.
Well, no shit, man. Really, there's airplane architecture. Really, there's shipbuilding architecture. Boy, this is really groundbreaking, Booch. You've really gone off. You've really let us know a lot of stuff here. So he mixes all this stuff together. So he's like doing marketing here, really. He's advertising his and he's getting people to all swimming around and this stuff. He's like being very like flippant. He's just being flippant.
So the term architecture is one that's very well respected outside the software engineering world.
Because then out where they actually mean something. There actually are real formal disciplines that you have to take it, but then we don't have that in software yet because it's still new. It's just like what 20, 30, 50 years old, maybe. Even then, we're still running on stuff that's based on the stuff from the 70s. And they say this is the state of the art. It's like that's a bunch of pile of crap. It's a bunch of crap on top of crap on top of crap on top of crap on top of crap that nobody understands anymore. That's why it still runs slow as fuck. And come on, man, we haven't seen it yet. This all has to be revamped and started from scratch up to the best. So we haven't seen the computer revolution yet. Somebody's gonna write an operating system that swamps these things and make them look like silly little goose eggs. And like they're gonna go beyond all this stuff. Yeah, we haven't seen that yet. It's still on the horizon. The stuff that Alan Kay's talking about. I'm not talking out my ass here. He's the one that described it, and it's legit. I've seen the results of it, and now we have the hardware to run it and AI tools to help people bring their concepts to life more. And then we have an operating system designed for that. I think that's a strong possibility that it exists, or somebody's being working on this thing, because the way the operating systems are laid out now with the Unix stuff, no.
Title for a moment, and let's go back to first principles. What is it at all? And you've probably heard me say this. All architecture is design, but not all design is architecture. Architecture represents the set of significant design decisions that shape the form and function of a system, where significant is measured by cost of change.
Right. The cost of change, meaning cost of figuring out something better. Yeah, the experiments and all the things go along with it to figure out the thing to begin with. Yeah, that's architecture. What problem are we solving for who? How are we solving it? And can we solve it faster, easier, cheaper, better, more fun than something else they have the alternative to doing? It's not complicated. It's very commonsensical stuff. But people want to put this shit around it to make themselves feel better and feel like, or avoid the issue. The direct issue is like solving someone's problem is the issue. Like, how do we solve it for them easier, faster, cheaper, funner?
So software architecture, an architect has this horrible emotional baggage around it. So
Yeah, it
think of it
should,
as
because
it's all about making
you guys
decisions.
were talking a bunch of crap, and then a bunch of people got to sit on their ass and call themselves, I'm an architect, and then order people who they assume would know everything because their UML diagrams are supposed to be completely understandable, right, in all details. It's like, and then you push that down onto the lowly programmers who have to go code this thing and figure out what the hell you're talking about. Yeah, definitely bad impression. You can't do that. They stop doing that. They think the AI is going to let them do that. It's like, no, it's not. I think it is though. All right, we're gonna go to what part 4? Yeah, I'm gonna do part 4. All right, give me a like and subscribe, and I'll continue my ranting.